Okay, so welcome to Math Time by the genius Nico, which is me. So today I'm gonna prove some cool differential stuff for you. Um, and by you I mean Benjamin, because I think you're probably the only one watching this. But anyways, I'm gonna prove it. So buckle up, be ready. Okay. So what I'm gonna show today is how to prove the power law rule, the addition rule, the product rule, the quotient rule, and last but not least, the chain rule. So all these rules apply to differential calculus, and that's why I've learned them uh, in order to find the derivative of different kinds of functions. So that's basically it. I think we should get started now. Okay, great. So first, the power law rule. I use this expression called x raised to the power of n, where n is a natural number here, you see, is equal to n times x raised to the power of n minus 1. So that's basically what it's telling me what I can do with the number. But proving it, I will first show you here. Here we have this is a function. This is just a normal function, x raised to the power of n. And this we got here, ladies and gentlemen, that is our differential quotient. That's what we use. I will use this throughout the whole video. Anyways, I'm applying my function into this formula, and then I'm expanding it. You can see there's a parenthesis here. So I'm expanding it and solving it, and then I do some factorization here in order to get rid of the, you can see, okay, x raised to the power of n minus x raised to the power of n is 0. So they cancel out each other. Then I factorize it, which means I also here these are divided by each other. They also cancel out each other. I apply the limit here, and this gives me the result that the derivative, the prime, f prime is in x. And here you see I have done the same thing here. I've just done it with the number, so it shows that the power rules give me the same result as the differential quotient. So that's my proof. Great. Next one coming up is addition rule. Great. A little trickier, but quite easy still. We got this function, and then we have our differential quotient as last time. I'm writing it here. You can see there is my, I have to write them each, so each has to be u of x plus delta x minus u of x, but here I've just rearranged it a little. It's just written like this, and here I've written it like it should be. And then my power rule says that I can just apply a limit to each of these. You can see this is a differential quotient, and this is also a differential quotient, and that gives me the result that the prime of this function is actually just the two primes of each number or letter or whatever we're working with here. So yeah, that's the proof. Now we're getting into something a little more difficult. I think this is the product rule. And here we got our function f of x equals u of x times v of x. Again, we are applying it, we're using this, we're going into we're writing it into the formula like we did the last time. And then in this step, now it gets tricky. We have to add u of x plus delta x times v of x minus u of x plus delta x times v of x. Because if I don't do this, then I can't analyze the different u and the different v. And also remember that even though I'm adding a lot of extra numbers here, the delta x is approaching 0, which means it's gonna be 0 eventually. So that makes it a little easier. So here, next step, rearranging. Then I begin applying the limits. I begin applying some limits. That's nice. And I begin dividing it up. Okay. So we can see here we got a v of x plus delta x, and then we got a u differential quotient, and it's like the opposite over here. And then last but not least, in order to solve this, I need to like apply my limit to each like part of it. As you can see here, this is again differential quotient, and that means that this is my result. This is how I find the prime of this. So it's a really long proof, I think. Quite complicated, quite difficult to explain, but I hope you get it, at least just a little. Now, something more, even more difficult. First, yeah, these are all the steps. We got our function, f of x equals u of x over v of x. Solving that, again, I just applied into the differential quotient function formula. Then it's getting like here, already here, I'm actually multiplying like this. I'm gonna multiply with v of x plus delta x times v of x over like the same. So that will give me this result. Ooh, nice, crazy, great. Because I don't want the brackets. That's just annoying for me. I don't like brackets. I've never liked it. I sucked at it actually when I learned it when I was like 9 years old. But anyways, we go down to this, and now there's more coming up. I'm gonna add v of x times u of x minus v of x times u of x, because I need to like, if I can't do that, I can't like solve it with the limits. Like I can't really do it. So you can see like this is positive and this is negative, so it's actually like it's gonna like eventually it's gonna like eliminate itself. So it's just like adding one or just like adding nothing. Like we just need extra numbers to solve this, okay? And that takes me down here. Some more numbers, very complicated. I don't like it. Then I'm gonna multiply here. I'm gonna multiply my whole function by 1 over delta x over 1 over delta x to get this. Yeah, crazy, nice, love it. But it makes life easier for me, and that means I can then start applying my limits in order to get rid of some numbers, which leads me to the result of this is gonna be that the prime of x equals v of x times u prime of x minus u of x times v prime of x divided by v of x squared. Yes, very nice, very complicated, but like here you got the proof, so you can actually just do it. It's not that difficult, really, but explaining it, I think it's hard, honestly. So this is my favorite part of differential calculus, like the chain rule. I don't know, I just think it's funny. So I thought it was a little hard to like explain, but I really tried. So what we know, like we got our the chain rule says that like the changes of x over the changes of u times the changes of u times the change of x. That's like the formula of the chain rule. That's like the prime. And here we got our we know what the change of u is. The change of u is u of x plus delta x minus u of x, and the change of y f is f of u plus plus delta u minus f of u. So that's like that is determined. And then we just like apply the limits. Here you can see I applied a little different limit that I've used in the previous exercises. I've used this limit, delta x approaching 0, but here I'm actually also using delta u. So that means like all these numbers, like it will eventually become this. So that this is my like my chain rule function. Like I think it's really hard to explain this part. I know in my assignment I have also done some exercises with it, and I hope that can like also give an understanding that I get this, but like I'm trying, But yeah, that's basically it. That was all of the rules. And so the question is, do I really understand this? And yeah, I understand the theory of it. I understand the, what I'm using it for. But honestly, I gotta say, with all these proofs and all these numbers and all these like delta x's, that like I'm really trying, but like I get it, but no, Dios mío, pero estoy intentando, weón. You have to like, that's like what I think inside, but I've really liked this material. I really liked learning about proofs and differential calculus, and I want to continue that. So I hope you enjoyed my video. I hope it wasn't that boring. And yeah, bye.